I am Zabelinor Akant. I'm going to tell you how we made this robot. So at first we went to base notes, selected robot. From robot we went to children, went to base notes and gave it a shape. From shape we named it body, and then we changed its appearance to BBR appearance, which will help to determine its visual properties. And then we changed its color from there. As you can see, this is white, and then we reduced its metalness to 0. Then from geometry null we gave it a box, and then from geometry box we changed its dimensions. From bounding object we used body, and then we added physics to this body. So now inertia, center of mass, and all the properties of physics will be applied to this box. Now, for wheels, we went to base nodes and selected hinge joint, and then we selected joint parameters, which will define the parameters of a hinge joint node. From device, we went to rotational motor. We selected rotational motor, which is used to generate a rotational motion around its hinge axis. And then from endpoint, we selected solid, and then we gave it a shape. And then we also changed its color to red after selecting PBR appearance. And then from geometry, we selected cylinder, and then we changed the height and radius of the cylinder. And then from endpoint solid, we also changed its translation values. X is 0.06, Y is 0.035, Z is 0.05. And then we also changed its rotational values so that it is vertical to the ground. Now we repeated the same process for all the other three wheels, but this time we did not start from scratch. This time we basically went to hinge joint, went to joint parameters, and then we used the first wheel for the rest of the three wheels. Then, from joint parameters, we found anchor values, which basically defines the axis of rotation. It attaches the wheels to a specific point initially with respect to the robot itself. So we set the anchor values equal to the translation values. Thank you.
Hello everyone, this is Mohammad Zubair Ahmed Fahim, and in this part of the video I'll be explaining the implementation of distance sensor and camera module that was integrated in our object detection robot. For creating the distance sensor, we have added a distance sensor from the base node, and then in the children subsection of the distance sensor we have added a shape for visualizing the sensor. The appearance is chosen to be PBR appearance and the geometry is chosen to be box. If we look at the front part of our robot, we have got two distance sensors which are slightly rotated to the right and to the left. We have achieved this by setting the translation to be 0.02, 0 and 0.1 and the rotation angle to be minus 1.27. For the right distance sensor, we have just tweaked this parameter where we set the translation to be minus 0.02, 0 and 0.1 and the rotation angle to be minus 1.87. We have also added collision properties and physics to these distance sensors because they're on the front part of our robot. For integrating the camera, we used a solid and given it a shape in the children for visualizing the object. The camera is added on the solid bar so that we can have a clear view of the front. For enhancing the camera clarity, we have increased the width and the height of the camera to 540 pixel. Now we haven't given any bounding object or physics to this camera because we don't actually need it since it's on the top of the robot, so it doesn't need any collision or physical physics property. Now, for adding the GPS sensors, we have added GPS from base node, and in the children subsection of GPS, we have added a solid, and then in the children subsection of the solid, we have added a appearance of PBR appearance and geometry of cylinder, which you can see on this part of our robot.
Hello, my name is Ziad Hassan Reza and I'm going to explain the next part. So here on this rectangular arena we have three oil barrels, one book, one cylinder, a cone and a sphere. We have added collision to all these objects and we turned on recognition color. And now I'm going to explain the code. So first we have included some libraries. We set the time step to 64, which means that after every 64 milliseconds the robot will update the values of its sensors and wheels. Then we add a pointer for the robot. We add two distance sensors, ds right and ds left. We say we enable the time step for the distance sensors. Then we add a camera. We enable the time step and recognition for the camera. Then we have four wheels, wheel 1, 2, 3, and 4. And for each wheel, the position is set to infinity, so it will keep moving, and the initial velocity is set to 0. And then while the value of time step is not equal to -1, which means that while the simulation is running, the left speed and right speed will be 1, which means that the robot will move in a straight line. And then if the distance sensor value is less than 950, which means that it is detecting an object, the avoid obstacle counter value will be 100. So in the next step, the value will be greater than 0, and the left speed will be 1 and the right speed will be -1, which means that the robot will turn right, and we will decrease the value of the obstacle counter. And here we set the value of wheel 0 and wheel 2 to left speed, and wheel 1 and wheel 3 to right speed. Thank you.
Everyone, we'd like to end this presentation by giving a slight overview of our project. Let's run this project now. As you can see, the robot is able to identify different objects which are given recognition colors, and when the robot gets close to an object, the distance sensor will detect an object, and it will turn right and change its direction and move on. Well, that was all from us. Thank you. I hope you like this project.